This is the review for applications of rational equations and variation. First question says for each write an equation that represents the statement. Okay, so it says Z varies jointly as A and B. So we know jointly, okay, means multiplication. So Z equals, and remember you always need a constant, which we use K for the constant. So K times A times B. Next one says P is directly proportional to the square root of M. Okay, so directly proportional. Okay, so P equals, remember we always need our constant, which is K. So directly proportional is going to be multiplication, the square root of M. Okay, let's look at the next one. Y varies inversely, and we know inversely means division, with X and Z. So Y varies inversely with X and Z. And remember again, you need your constant, so we're going to put K on the top there. All right, next we have Y is inversely proportional with Z and directly proportional to the square of X. So we have Y equals, we know we have to put our constant in there, so we have K. So inversely proportional to Z, so that's going to go in our denominator, and directly proportional with the square of X. So that's the same thing as saying X squared. Okay, so these are just reading and then writing our equation. All right, let's look at the next one. Write a function that models the variation. Z varies directly with X and inversely with the cube of Y. And then they give me variables for X, Y, and Z. So the first thing we're going to do is we're going to write our equation. So it says Z varies directly with X and inversely with the cube of Y. The cube of Y is Y cubed. Don't forget you need your constant. All right, so once we have our equation, they give us information so we can substitute in because we don't know what K is. So first thing we need to do is we need to figure out what K is, which is our constant. So we're going to substitute. I have X equals 8, Y equals 2, Z equals 3. So 3 equals K times 8 over 2 cubed. Remember, K is what we're looking for. So now we can simplify this. 2 cubed is 8. So 3 equals K times 8 over 8. Okay, well 8 divided by 8 is 1. So K equals 3. All right, so then our final answer, we're going to use this and we're going to substitute back into our equation. So we have our final equation. Z equals 3x over y cubed. So that will be our final answer right there. So not until you find your value of K have you written the function. So this will be our final answer right here. All right, next it says given the model from part A, find Z. Okay, so they want us to solve for Z, and they've given us X, and they've given us Y. And we know that our constant is 3. So Z equals 3 times, I'm just substituting, 6 over 4 cubed. Okay, we could put that into the calculator. Remember to get the fraction line, we can go alpha Y equals. So I have 3 times 6 over 4 to the power of 3, arrow out, enter. So 9 over 32. Oops. And then 9 divided by 32. as a decimal is 0.28125. So depending on the instructions, either one of those answers are acceptable. Okay, the other thing on the test is you need to be able to read a word problem and kind of go through these steps, setting up the equation, finding out what your constant is, and then answering whatever question that they've given you. Okay, so these do take multiple steps. So let's read the first one. It takes to landscape a lawn is inversely proportional to the number of workers. If 10 workers can do a job in 2 days, then 4 workers can do the same job in how many days? All right, so the first thing I told you was to assign variables to the pieces of information. So I have time, the time it takes, so I'm going to say T is time. Okay. It takes to landscape a lawn is inversely proportional, so we know inversely means we're going to have divided by, to the number of workers. So workers is going to be W. Okay, so the amount of time it takes is inversely proportional to the number of workers. All right, so basically we're taking what we did up here, but we're using a real world example and giving ourselves some variables and then setting up our function. Now, we have to figure out what K is. Remember, we can't leave it as K. If 10 workers, so I have W equals 10, can do a job in 2 days, so time equals 2 days. So this is enough information to find K. So let's go ahead and substitute that in so we can find K. So 2 equals K over 10 times 10 on both sides, because we're going to solve for K here. So K equals 20. So that's our constant. So our function would be T equals 20 over W. Now with this information, you could give me however many workers you had or whatever, how much time you were allotting, and you could find the other thing. So let's see what it asks us. It says, then 4 workers can do the same job in how many days? 4 workers. So now it's saying that I know that W is 4, and they want to know how much time it takes. Well, now that we have our equation, T equals 20 over 4. 20 divided by 4 is 5, so it would take 5 days. Okay. Again, this is the process. You have to figure out the variables, write your function, substitute to find K, and then answer the question. So this is quite a few steps. Now let's look at the next one. It says, find the constant of variation K and the direct variation equation if Y varies directly with X. Okay, so Y varies directly with X. They want to know what is K, and then what is my equation. All right, so I have 14. They told me here I'm going to substitute in because I've got to find K first. 14 equals K times 7. I want to know what K is, so I'm going to divide by 7. So K equals 2. So there's our constant variation right here. So this is our constant variation. And then it wants to know what the equation is. So for our equation, it would be Y equals 2X. So our direct variation equation is Y equals 2X. That's all we needed to do for that one. All right, let's look at the next one. Write an equation that represents the statement Z is jointly proportional to X and Y and inversely proportional to the square of G. Okay, so it's basically the same thing we were doing up here. It just looks like it's a little different the way that it's worded, but it's the same thing. So Z is jointly proportional to X and Y. So jointly proportional to X and Y, and inversely proportional to the square of G. Don't forget we need K, and K is always in our numerator, so we put our K in. Z is jointly proportional to X and Y, and inversely proportional. Whenever you see that word inverse, you should be putting that division line, G squared, or the square of G, which is the same thing as G squared. All right, let's look at the next problem. Oops. Kinetic energy varies jointly as the mass of the square of the velocity. The mass of 6 grams and the velocity of 2 centimeters per second have a kinetic energy of 108 ergs. Find the kinetic energy for a mass of 15 grams and a velocity of 8 centimeters per second. Okay, so this one's pretty complicated. But again, it's the same thing. It's just that we have a lot of variables here. Okay, so it says kinetic energy. So the first thing I'm going to do is I'm going to assign some variables. Kinetic energy, we'll call that K, varies jointly, we'll come back to that, as the mass, so we'll do mass of M, and the square of the velocity. Okay, so I'm not even going to go any further than that. So I've got my variables assigned. Now I need to write my equation. All right, before I write my equation, I want to change this variable because we know that we use K for our constant. So I actually want to change kinetic energy to E instead of K. So kinetic energy varies jointly with mass and the square of velocity. So kinetic energy varies jointly with mass and the square of velocity. Square of means velocity squared. Okay? Now, I know some of you are thinking square root. It's not a square root. It's the square of velocity. All right? Okay, so now, remember we've got to find K. That's our second step, is to find K. So, a mass of 6 grams, so I have M equals 6, and a velocity of 3, so velocity equals 3, has a kinetic energy, which is E, of 108. All right, again, I'm going to stop there. I'm going to look at these. I'm going to substitute them in because I have to find what K is. So I have 108 equals K, I don't know, the mass times the velocity squared. Okay, so this one you're going to have to solve. 108 equals 6 times 3 squared, 6 times 3 squared, so 54. So K times 54. We're going to divide both sides by 54 because I want to know what K is. So 108 divided by 54, K is equal to 2. All right, so I'm going to rewrite my equation. I have the equation here, and now I know what K is. So E equals 2 times M times V squared. We're not done. Now it says find the kinetic energy for a mass of 15 grams and a velocity of 8 centimeters per second. Okay, so I want to know what my kinetic energy is when I have a mass of 15, M equals 15, and velocity, V equals 8. So substituting it in, I have 8 squared. Now I don't need to solve this, I'm just going to simplify, put this in the calculator. 2 times 15 times 8 squared. So that gives me 20. So kinetic energy is 1,920. All right, let's look at the next one. Some students volunteered to clean up the highway near the school. The amount of time it takes varies directly with the length of the section of highway and inversely with the number of students who will help. If 25 students clean up 5 miles of highway, the project will take 2 hours. how long will it take 85 students to clean up 34 miles of highway? All right, let's assign variables. So some students volunteered to clean up the highway at their school. So the amount of time it takes varies directly, we're going to need that in a second, with the length of the section of the highway. So length looks, L looks like a 1, so let's use G for length. The section of the highway, and inversely with the number of students. So I used S for students, okay? So now we need to write our equation. I'm not even going to read anything else. I'm going to stop there. Let's write our equation. So the amount of time it takes varies directly with the length of the section of the highway. So we said length of the section was G. And inversely, remember inversely, we're going to make our divided by the number of students. All right, so there's our equation, but we have to find K. So let's read on. It says if 25 students, so S equals 25, clean up 5 miles, so length is 5, the project will take 2 hours. All right, so remember for this step right here is we're solving for K. So let's substitute in. We have 2 is the time equals K times the length, which is G, over the number of students, which is 25. So 2 equals 5 divided by 25 can reduce to K over 5 times 5 on both sides. It goes away. K equals 10. All right, let's write our equation. T equals 10G over S. Now let's see what it asks us. How long would it take 85 students to clean up 34 miles of highway? So how long, I don't know T, would it take 85 students to clean up 34 miles of highway? All I did was S equals 85, G equals 34, and I substituted into our equation. Okay, I'm going to put that in my calculator. 10 times 34 divided by 85 equals 4. So it takes 4 hours. All right, next one. It says the volume of a cone varies jointly as its height and the square of its radius. The cone with a radius of 6 inches and a height of 10 inches has a volume of 120 pi cubic inches. Find the volume of the cone having the radius of 15 and a height of 7 inches. All these problems are the same. Assigning variables, writing your equation, solving for K, and then answering the problem. So I'm going to start to move a little faster. It says volume, so V equals volume of a cone varies jointly with its height and the square of its radius. I'm stopping there. Okay, now I can write my equation. Volume varies jointly, and I'll have a K, so jointly with height and the square of its radius. Okay, a cone has a radius of 6, so R equals 6, and a height of 10, has a volume of 120 pi. I need to know what my constant is, so I'm going to substitute in 120 pi equals K, I don't know, times my height times my radius squared. So 120 pi equals K, 10 times 6 squared, 360. Divide both sides by 360. Okay. Remember pi, I'm going to leave the pi into the equation to make it simpler. I'll show you actually both ways to do it. So 120 divided by 360. Okay, so that's 1/3 pi. If you had multiplied that out 1/3, so 1/3 times pi, remember the pi button is right there. That would have given us 1.05, which is equivalent to 1.05. So you could use either. I'm going to use the more accurate, which is my 1/3 pi. Okay, so then the next says find the volume of a cone having a radius of 15 inches and a height of 7 inches. I know you're excited because this is geometry. Hopefully you remember doing this. So what is the volume? I don't know the volume. I know my constant is 1/3 pi times the radius and the height of 10. So I have, height of 7. So I have times 7 times my radius squared. So all I did was take our equation here. Volume equals, we know what K is, 1/3 pi times the height times the radius squared. And they gave me the radius, and then they gave me the height. Okay, so let's put that into the calculator. So I have 1/3 times pi times 7 times 15 squared. It gives me approximately 1,649.34 inches cubed. Okay. All right, last one. The electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. A wire with a length of 200 inches and a diameter of 1/4 of an inch has a resistance of 20 ohms. Find the electrical resistance of a 500-inch wire with the same diameter. Okay, same process. Electrical resistance. We're going to say that's R. Electrical resistance of wires varies directly with the length. I like to write all of this out. Now length again, I don't like using L, so I'm going to use G. And inversely with the square of its diameter. Okay. All right, next is writing my equation. So the electrical resistance varies directly with the length and inversely with the square of its diameter. Okay. Now we've got to figure out what K is. A wire with a length of 200 inches and a diameter of 1/4 of an inch, 1/4 of an inch, has a resistance of 20 ohms. So we've got to find K now. Before we do anything, we have to find K. So 20 equals K times 200 over 1/4. Okay, so that's 1/4 squared, because remember our diameter is squared. So I'm going to put this whole thing into the calculator. All right, except, well, I'm going to put the right side of the equation without the K into the calculator, because I know that this looks terrifying. So we're going to do alpha y equals 200 divided by, well, this is another fraction. That's fine. Do alpha y equals again. And we're going to do 1/4. And that 1/4 is squared. Oops. But remember, the whole thing is squared, not just the top. The entire thing is squared. So I just took exactly what I wrote on my paper and put it in the calculator. I'm going to press enter. So that's going to give me 3,200 times K. So I'm going to divide by both sides by 3,200. So 20 divided by 3,200 gives me 0.00625. So K equals 0.00625. And I'm not going to chop off any decimals. You could also use it as a fraction if you said math, enter. That would given you 1 over 160. Either is fine. Alright, so I'm going to substitute in my K now that I know it. So 1 over 160 times G all over D squared. So let's read the rest of the problem. It says find the electrical resistance in a 500-inch wire. Okay, so that's my length. So G equals 500 with the same diameter. So D equals 1/4. It says the same as the other one. Alright, so let's substitute in R equals 1 over 160 times 500 all over 1/4 squared. Alright, I'm going to put this whole thing in the calculator. You could do it piece by piece. I'm just going to do it all together. Okay, alpha y equals, so I need another alpha y equals 1 divided by 160. Oops. 160. Arrow over because that's times 500. And then on the bottom I have 1 divided by 4, and that whole thing is squared. So that's going to give me the resistance equals 50 ohms. Okay, and that's it. Your quiz is next class.